My name is Bhasker Ravikanti. I'm the Senior IT Fellow at Honeywell. Thank you all for coming for one of these last sessions of the day. I'm going to present about our implementation of hyper-converged and converged storage platforms. This project is still underway. We're not 100% done. We have another couple of months to complete. I lead a team of architects in the area of ERP and analytics at Honeywell. I've been working there for 20 years. This is my second presentation. A few years back, I presented at Orlando conference on disaster recovery. I also presented a couple of papers at the Oracle World a few years back and also SAP TechEd. So we are primarily the consumers of this technology. We are hearing about all these new features, new things coming up. Various presentations are highly technical, but by the time industry adopts them and you start to use them, it will be a few years. So this topic about hyper-converged and converged platforms are something that I learned a few years back at one of these conferences, and now we are able to go and implement them. There are a couple of reasons, because our ERP systems are very large in size, and that means the technology, sometimes virtualization and cloud is not always, we cannot readily adapt to those technologies because of how large these databases are and some of the performance characteristics that we require. So quickly we go through introduction of Honeywell as a company, $40 billion in 4 different divisions: aerospace, homes and building technologies, performance materials, and safety and productivity solutions. And in terms of ERP, each of these business units have their own single global instance, and the users are worldwide and the factories are worldwide, but they all connect to these centralized ERP systems. And in terms of criticality, these are business critical, and typically you need to have a local failover and disaster recovery. All those things need to be in place. And then recently Honeywell has announced 2 spin-offs. And also a few years back, the direction of the company has changed, like everyone else, from the industrials company towards services-oriented company, because that's where everyone is going. So now there's a connected aircraft, connected automobile, everything is, connected platforms are becoming huge. And Honeywell has opened a software center in Atlanta, recruiting only software engineers in that center. And last year, 2 spin-offs were announced. One is what used to be a transportation systems. It was a subsidiary under aerospace, is now becoming Garrett Advancing Motion. And the other part is Residio. It is what used to be called Homes, under Homes and Building Technologies. And it's also, they're keeping the name Honeywell Home because everyone is familiar with the Honeywell product thermostat. And so the Garrett is becoming publicly traded company starting next week on October 1st. And then Residio will be pretty soon, by end of the year, it will be a separate company. Together, these are about 20%, and each one is about 10%. And in terms of ERP, transportation systems, originally it was a independent business, so it has its own completely separated ERP systems. So when they're becoming a separate company, they'll just gonna take all those systems with them, so it's called a give and go concept. Whereas homes was integrated into our homes and buildings and SPS divisions. And when it's spinning off, all the ERP systems and everything need to be, we had to clone it, make a duplicate copy, and so that by, there's a security commission rules that there is a certain period by which they had to vacate the Honeywell data centers. So for day one, which is when it officially starts trading on the stock exchange, they can reside at Honeywell, but by day two, typically 12 to 18 months, they had to vacate Honeywell. So as part of the spin-off, we also ended up cloning all the big ERP systems for the Residio division. And as I was mentioning, primarily our ERP system is SAP, and there's OLTP and analytics. And analytics, it traditionally started as an Oracle database, data warehouses, but a few years back, we also started implementing the in-memory from SAP, the HANA. And in terms of technology, the HANA is still, there's a limited extent by which you can virtualize them in terms of, if you want to run in a cloud. Amazon supports very large footprint because typically in-memory systems, they require large amount of memory. And there's a scale up and scale out and two different architectures. Typically for analytics, it's a scale out. But if we want to virtualize them, only single node configurations are certified by SAP. So in our implementation, we ended up going with a physical architecture for the analytics databases for HANA, and everything else we are virtualizing. And historically, our ERP systems were, typically on a SAN storage. Systems like these running on AIX with very large SAN storage attached to the servers. And every few years, we upgrade them to a bigger and bigger servers to accommodate for the performance needs, and also the databases grow about 20% per year. And about 10 to 12 years ago, when we started our 3 terabytes database, we were struggling to manage the performance and backups and recovery, and now all these years, these are 30 to 40 terabytes. And the analytics portion is now about 60 terabytes. And in a typical SAN, we have a local copy, and then we have a remote copy, disaster recovery network in 2 data centers, primary and secondary. Both are Honeywell owned. The primary data center it evolved over a period of 30 years. Sorry, let me go back here. And so 3 years back, one of the SBGs, we moved to a pre-configured architecture like a vBlock. But internally, it's still, there's a network component and a compute network in one cabinet and the storage in the other cabinet. And we implemented this way. And this also results in you had to move the AIX cross-platform migration from AIX to Red Hat. And 90% we implemented in virtualization using VMware, but the one large database, we kept it in a bare metal inside this platform. And then replication will be using the Recover Point physical appliances that split the data and send it to the over the wire to the remote data center. So this worked out well from the performance and other benefits. But when it comes to the expansion, there's a couple of issues. One is, once you run out of capacity inside the cabinet, now you have to bring in a whole new full-size cabinet, even if you're adding 10, 20 terabytes of storage. And then also it requires physically co-location to the existing cabinet. So you can only put them very close. You cannot be any other corner in the data center. And also, I was talking about our data center. 3 years ago, Honeywell decided to move to a brand new data center, vacate the one that was evolving over the period of 30 years. So we decided to go to a colo, rent a space in a huge public data center from CyrusOne, and then implement a completely new architecture, SAN-free, and all Ethernet-based protocols, TCP, and everything. So in terms of our going back to our ERP, some of the critical performance factors when we are moving to a new data center, the Oracle database, metrics are pretty much, how fast it's reading the data from the disk. Anything between 5 milliseconds and less, and if it start deteriorating from there, immediately the users will start complaining because again, we have batch jobs running 24 hours a day, and then and the transactions, end users, all happening around the clock, and the Oracle writes typically log file sync, that wait time cannot exceed about 10-15 milliseconds. Then again, the commits will be slowing down. In terms of IOPS, we have a typical architecture. We have a big database server and about 30 to 40 application servers. But in our existing legacy data center, these are all connected by a 1 gig network. So sometimes the SAN becomes a bottleneck. Sometimes the database server to the application server traffic is going only through the 1 gig. So now 40 of the app servers are connected to one database server. So they're all sharing that 1 gig network, even though we have a customer traffic separated and then application server database traffic in a separate network, but each only limited by 1 gig. So decided to, when we go to the new data center, some of these bottlenecks we wanted to eliminate. Particularly the 1 gig network is now become a minimum of 10, 40, and 100 gig in a leaf and spine architecture. So and also the objective was to go completely SAN free, but now we are running out of time, and in some other applications in the areas that we had some very old HPUX equipment, and the migration of those applications will be multi-year projects. So there are some of them being physically relocated with some small footprint of SAN storage. So about 2 years ago, when in the new refresh for the ERP, we started looking at what platform to select. And and we're looking at this Gartner recommendation about who is ahead in terms of hyperconverged infrastructure services. And we decided to go with the Nutanix. At that time, they were, it used to be a hardware company. Now they are only software only. They had a partnership with Dell, who is also our suppliers, because most of our equipment was running on Dell servers. So when we selected this platform for SAP, we worked with them to do the proper sizing. One of the SBGs where the database was about 12 terabytes. So there are two types again. The node types, the way we are designating is if it's all SSD drives, it's a high speed, high performance node, good for production workloads. And for the other dev and QA systems, they can run on these nodes with the regular traditional hard drives. And the Nutanix software, and these are all running VMware. That's a Honeywell standard. So in a logical view, and there's a bottom section is a physical view. All the physical nodes are running, and the Nutanix runs a virtual machine at the hypervisor level called the controller virtual machine, and that's what hiding the physical storage from the hypervisor. And hypervisor level, it looks like one big chunk of storage, not individually, where each node capacity is limited to. And then, of course, VMware will use the CPU and memory available at the node. And then the application will be, now the database can have more storage because of the controller VM is managing the storage across the nodes. That also could be a limitation when your database size is very large, right? Like as long as it fits in the physical one node, then all your local reads will be served out of that. And the writes, of course, Nutanix architecture dictates you need to have at least one redundancy. So that means at least one other node in the cluster will have a copy of the data. So if the node goes down, then your VM can still be up and running with the other surviving node providing and taking over. And then immediately the duplication of data starts based on the +1 or +2 redundancy levels. So in this, using these nodes in our data center now, every rack will have these nodes, and we connected 4 10 gig networks to the top of the rack switches. They connect to the spines. So in the expansion-wise, in the future, if we have to expand, that again the new node can be some other part of the data center, but the unit of expansion is very small and affordable. So for our starting with our primary, one of the SBGs, as I was saying, we went with the 6 nodes for the production, and the disaster recovery will have the equivalent size. And we are using the recover point for VM from Dell EMC. That's a virtual replication tool. It again works at the hypervisor level, splitting the data and sending it across over the network to the remote location. And for the dev and QA non-production, we have another 16 nodes, and then those configuration, there are 20 hard drives and 4 SSDs for cache storage. And we have one of the other SBG, we started implementing this, and then what happened is that we've been working with Nutanix, and we know that for our large footprints, we needed a bigger storage, bigger footprint. And Nutanix was telling us they will release in the second quarter last year that second or third quarter will have a 4-socket machines and more storage. But since that didn't happen on time, and we had a spin-off announced, and we had a limited time. By the time we had to implement for one of the spin cores, a clone, by July of this year. So we ended up selecting another option. But let me go through some of the benefits that we already discussed through this. So it's a good platform as long as the database fits in a single node. Once it exceeds that, then the performance could become a issue because the controller VMs are communicating across the network for the writes and the reads also. And the compression is available at the storage level. But when we moved to this platform, we were able to remove Oracle compression, which is a licensed product. Now we're able to use compression at the native. There's also deduplication available, which is good for the application server type of workloads, because when you have multiple copies of those at the storage level, it only uses one copy and still be able to provision multiple VMs with the same storage. They also have a hypervisor included, but which is fully certified by SAP. But Honeywell, we went with VMware. That's our company standard. And also the DR replication is also available. But again, we went with a different tool for that. Then there's a call home feature, proactive hardware failure So some of these features are available at the hyperconverged. And the limitations are like not enough compute, and the performance could be a bottleneck if the workload doesn't fit on a single node, and either whether you want to scale out, either you need memory, CPU, or storage, then you will be adding a node. That means you're adding compute, memory, and storage. And then recently they also announced storage-only nodes that are capable of, there's more storage, less compute and memory. And so for our larger workloads, we decided to go with a Dell EMC Scale I/O platform, which is also called the FlexOS. Right now, I think that's rebranded as FlexOS, where the storage is not heavy in compute or memory. These storage nodes serve for either production or dev and QA based on the, we have, for the dev and QA, there's a lot of capacity per node because they're traditional hard drives. You can go up to 22. And then the SSD, again, they limit at 10 because of even if you had more SSDs, there's not enough CPU to send the data across the node. So that's a limitation right now. And then we are separating the compute and storage. That's so the compute, we selected a 4-socket with 3 terabytes of memory. So these are just for the hypervisor hosts running VMware. And in this, again, the storage is virtualized. The way it is done is a little bit different. What Scale I/O has is that there's a SDC component running at the VMware level. It's called the storage data client. And it can talk to the bottom portion, the storage data server, that's serving the storage from the individual. But then again, it's at the VMware level, it appears like a one big storage, and you can carve out databases as large as 62 terabytes per single data store. The database can be bigger than that, but the single data store right now limited by VMware. And then there's a metadata manager that kind of manages. It's a master and 2 slaves. That's only in the initial stages, but it's not in the communication between the client and the server. The client is directly talking to the storage servers. So there's no intermediate. It doesn't go through MDM. And again, like hyperconverged, you can choose your redundancy. Again, minimum level 1. There's always one extra copy of the storage, but it's not by node because the data can be striped across multiple nodes. But there's always a map where my database is, where my storage is, and then there's also a second copy of it in the pool. And because now these are becoming more and more as compute and storage is separated, we improve the network. So the rack, now we upgraded to 4 40 gig connections, and then the spine uplinks, we changed it to 600 gig connections. And in our data center architecture, our data center team recommended that we put all the compute in one rack and the storage node in another rack because of the power consumptions were different, power cables are different. So we ended up putting compute all in one rack and storage in a couple of racks like that. But the future expansion, they could be anywhere. So one of the SPGs, this is a virtualized with 12 nodes, 12 hypervisor nodes, and a large pool of hybrid and SSD storage pools, and then using the recover point tool for replication. between the primary and for the DR. And the other SBG, if you notice the arrow is in other direction, so what was the DR for the one SBG is now the primary for the second SBG. And our storage in all these clusters are segregated by data classification, because aerospace has clients in defense and space, so there's an export compliance, ITAR compliance for the data. So these VMware clusters and the storage is pretty much whether your data is ITAR or non-ITAR. So that's how we separated the VMware clusters and the storage pools. So the advantage is like independently scalable compute and storage, and you can easily scale up the performance by adding more nodes. Dynamically, it rebalances as soon as you add a node. It uses some cycles, not impacting your production workloads, but they all rebalance. So whatever if you are consuming 10 nodes before, and as soon as you add a couple of more, all the data from those 10 nodes will start moving, so that they are all, again, balancing in terms of utilization. If there was 80% full, now they all go down to 70% to consume the extra capacity. And same thing happens when you take the nodes out. Typically, you put in a maintenance mode, and then you can remove it from the pool. And that's also like for the future refresh. You don't have to be 100% identical in terms of architecture. You can. I mean, in a couple of years, there will be newer models, but they can be added to this pool. So right now, again, this is very, very new from Dell. So some of these features that are available on Nutanix are not available here, like compression and deduplication. They're coming up with those. And also some of those very, very basic traditional features in the SAN arrays, like what you call a time finder copy or flash copy, available at the SAN level. And those are available at the platform level at the scale I/O, but with the virtualization, the VMware, we don't have those features right now. So that's a limitation we're seeing. And then probably it's not a huge problem, but a single storage pool, you can have 512 volumes. So we said each, like for example, in the hybrid world, you have 22 hard drives plus 2 SSDs, so 24. So that's translates to 13 nodes per storage pool, but you can also create multiple storage pools, and still at the hypervisor level, you can provision storage from multiple pools. That's not a problem. So we are still implementing this, and we don't have all the data like we have from the SAN implementation, but the preliminary results that we had are very, very positive. So we have in another couple of months, we'll be completing this migration, vacating our data center to these new platforms. Okay, if you don't have any questions, thank you for attending. Appreciate it.